Superantigens. Superantigens are immunostimulatory molecules that are produced by bacteria and viruses. This immunostimulatory molecule are either present in the outer membrane of bacteria or they are produced inside the cell of bacteria and virus and released to the external environment as a mature protein. Now, the reason why the superantigen is so much in discussion is because of their potent effect. They cause a wide variety of effects like from food poisoning to toxic shock syndrome to pathogenesis of autoimmune diseases and also pathogenesis or development of immunodeficiency. Now this disease has this wide range of effect because of the unique fact that this super antigen, unlike the antigen, are able to escape the processing of the antigen that occurs in the macrophage, and as a result of this the T cell activation that is brought about by the normal antigen, which is very specific, is not done by the super antigen. The T cell activation that the super antigen does is a very non-specific. As the T cells, the activation is non-specific, so a wide variety of T cells that are sensitive to various different antigens are activated, as a result of which we see a wide variety of T cells activation, and in turn that causes a wide variety of activation of non-specific B cells and also release of huge amount of cytokines. As a result of this, the entire immune response, excessive immune response can cause even coma and death. Hello friends, I am Dr. Antika Das, and in this video I am going to solve a GSET question that regards the antigen, super antigen and complementary system. Though in this is a set based question, but it is also in the MSc and BSc syllabus, so those who are in MSc and BSc can also watch this video and it will be helpful for them also. Now this is the question that I was mentioning from the GSET. Now that in November we have this Gujarat set, so I'll be solving a series of questions that comes in the previous GSET question papers. So let's see. So this super antigen, it is a question about super antigen, and the options are that it binds to the FAB portion of immunoglobulin G that is bound to the B cells, or it activates the alternate pathway of the complement system which is in the innate immunity, or the super antigen has a dominant epitope of amino acid repeat sequences, or the super antigen binds to the T cell receptors B beta region and the MHC class 2 molecule of the macrophage or any other antigen presenting cell. So these are the four options and we have to select the correct options. So let's see, I'll be first discussing the super antigen and the complement system, and then we will be able to solve the question. Super antigens. Now super antigens, as we have already seen, these are immunostimulatory molecule. Mostly staphylococcus and streptococcus are the bacteria that are commonly causing this, they release this super antigen. Apart from that, we have also other microbes like mycoplasma, Pterostreptococcus, rabies, and even Yersinia, and among virus, Epstein-Barr virus also release this super antigens. Now, this super antigen, as we have already seen, that it does not specifically bind to the T cell as well as the antigen presenting cell. So the T cell that it activates can be a variety of T cells, as there is no specific binding. It can bind with any T cell, and as a result it can stimulate many type of T cells and produce a wide range of cytokines in huge amount, and as a result of which we see a host of diseases like diabetes mellitus, eczema, psoriasis, arthritis, rheumatic fever, scarlet fever, Kawasaki disease, infective endocarditis, that is in the heart, and toxic shock syndrome. In toxic shock syndrome, we see not only the common symptoms of fever, MSAs, diarrhea, sunburn, but also and sore throat, but also very in the very late stages of toxic syndrome, we can see the peeling of skin layer by layer. Now, all these diseases, they are caused due to the huge amount of cytokines or the inflammatory compounds that are produced. They not only create damage to a particular tissue that is infected, but also all the multi-organ damage, and also they create havoc with the entire immune system. The immune system, they are fooled, and they activate a lot of T cells, a wide variety of T cells, and as a result of which there is hyperactivity in the immunology of our body, in the immune system of our body, and as a result of this, we see that not only this inflammation, but also allergy, and also massive killing of various cells of various organs, and all these are found. And why all these things happen, that I am going to discuss in the next slide. So this is the action mechanism. Here in this diagram we see that this is an antigen presenting cell, which can be mast cell, dendritic cell, macrophage or B cell, whatever. These antigen presenting cell, normally what it does is, if there is a antigen, if there is an antigen, this is the antigen. So it is this antigen presenting cell, it phagocytizes the antigen, and then it breaks down the antigen into antigenic peptides, and then present that peptide, this one here, present this peptide to the T helper cell. But the super antigen, it is not the case. The antigen, it binds specifically. Any particular antigen has a specific receptor, specific T cell receptor for it. But in the super antigen, we see that it binds non-specifically. It does not here. This is the antigen, and it binds specifically, but in case of super antigen, such specificity is not found. And in fact, many super antigens, they have almost similar domains, so they can bind non-specifically to various type of T cells. By various type of T cells, I mean that T cells that are specific for, say for example, antigen A, the T cell that is specific for antigen A1 can bind with the super antigen, as well as T cell that is specific for, say, antigen A2 will also be able to bind with this super antigen. In this way, super antigen can bind with a wide variety of T cells non-specifically, as a result of which the T cells, a wide variety of T cells are activated, which in turn activate a wide variety of B cells. So this T helper cell in turn activate the B cells. They activate the B cells and also they produce inflammatory cytokines. Cytokines. So we see that there are this wide variety of B cells are activated, as well as a huge amount of cytokines is activated, because wide variety of T cell is activated, and once the T cell is activated, it will release cytokine. As not a particular specific T cell is activated, a wide variety of T cell activated, so we see the amount of cytokine generated is also huge, and also we see that the number of B cell activated is also a wide variety. As a result, a wide variety of antibodies will also be produced. So this is basically the action mechanism, how this super antigen, they produce hyperimmunological response, and these are the wide variety of cytokines that are released by this non-specific attachment of the super antigen. So there are many effects, that is the direct and the indirect effect. So in the direct effect, super antigen, what it does is that it as because it is non-specific binding, so the memory cells, the memory T cells as well as the memory B cells that is produced following a super antigen exposure will not be effective in creating response if there is a normal antigen stimulation. And also, if there is a normal antigen stimulation, then they will not be able to create memory cell that will be helpful in the super antigen exposure. So in this way, we see that the super antigen, they are exposure, they are unresponsive to the normal antigen stimulation and vice versa. So this in turn, they create immune deficiency in the long course. Also, by this super antigen activity, what happens is that any bacteria that super antigen direct effect. Now, due to the non-specific activation of the T cells and in turn B cells, a great variety of cytokines is also released. Apart from a great variety of activation of the T cells and B cells, so these cytokines, all these interleukin 1, interleukin 2, interleukin 6, INF gamma, TNF alpha, all this, they start attacking the body cells. The immune system, it stops distinguishing between, it is unable to distinguish between self and non-self cells, and that causes this autoimmunity. Another direct effect of super antigen is the isotype switching of the antibody production. It is activated by this super antigen, because the body is unable to get any specific is unable to find out what type of antigen is attacking the body, so it starts isotype switching and producing different varieties of this interferon, immunoglobulin gamma, immunoglobulin M, IgE. So these all isotype switching is also induced by super antigen, and as a result of this, cytokine production as well as the complement fixation that is activated by the endotoxins, that is the alternate pathway, the tissue damage as well as organ damage can be seen. This is because of the membrane attack complex that occur as a result of the complement system. Complement system I'll be discussing later in the later part of the video. So another direct, all this cytokine release and tissue damage, it is manifested by these symptoms, that is inflammation, rashes, fever, organ failure, and ultimately maximum it can cause even. There are also indirect effects of superantigen. The indirect effect includes inducing mitosis, that is the mitogenic activity in the cell. It induces mitogenic activity of the immune cells, and also the superantigens, it stimulates and attracts the neutrophils to the site of infection. As a result, these neutrophils, they cause much of the tissue destruction in the affected area. Also, it causes monocyte activation. Now, once the monocytes are activated, then what does it produce? It produces the antigen presenting cells. For example, the mast cells, the dendritic cells, and the macrophages. These are produced from the monocytes. And so monocyte activation produces these T type of antigen presenting cells. Then also due to superantigen, we see that progression of superantigen infection, it causes sepsis as well as damage to the endothelial system, as well as circulatory shock and multi-organ failure. So we see that both direct and indirect effect leads to the same thing, that is multi-organ failure and multiple tissue damage, organ damage, and ultimately it causes coma and death. So we see that both the superantigen, direct, indirect, they have ultimately the same effect, and the superantigen, they are usually caused, they are not usually, they are always they causes non-specific activation. Non-specific activation of T and B cell is the most important thing that distinguishes a superantigen from an antigen. Now, earlier we have seen that superantigen, it binds with the T cells, T helper cells, and the MAC2 of the macrophage or any other antigen presenting cell. But here we are going to see how the B cell, it interacts with the superantigen. So this is a B cell. This is a B cell, and this is the IgG that is bound on the surface of the B cell. That is this is the C region. This is the C region of the IgG, and this is the variable region which binds with the red color superantigen. Here, this is the superantigen that is bound, and we see that this superantigen again attracts other type of immunoglobulins. These immunoglobulin, here it is shown that they are free, but most of the time the immunoglobulins, these immunoglobulins, I'm drawing it in another color, these immunoglobulins, what we are seeing, these immunoglobulins, they are in fact, they are attached to either the mast cells or the basophil cells. So this superantigen, they on one hand they bind with the immunoglobulin G of the B cell, and on the other hand they bind with the free antigen or antigen bind to the mast cells or basophil cells. So in this way, it binds with two type of cells or free antigen or the B cell, and in turn it also activates the mast and the basophil cells. They are the, we know that they are the antigen presenting cells, and all the antigen presenting cells, they have this release. Once they identify any antigen, they will be releasing inflammatory cytokines. So as a result, this after the opsonization of these B cells, cytokines are also released by the mast and the basophil cells, and this B cell, it is targeted for this apoptosis or phagocytosis depending upon the mechanism. About the complement system, we know that complement proteins, they are proteins that are present in our blood. They are actually synthesized in the liver, and then they, with the help of blood, they circulate our body in inactive form, and they are activated by various mechanisms, and only after activation they help in our immunity. So the first process by which these plasma proteins in the that is a complement cell proteins, they are activated is the classical pathway, that is activated by this antigen antibody reaction. That is, antigen is a foreign protein that is recognized by this antibody, and this reaction brings about the classical pathway, where this antigen antibody reaction, it activates the C1, which in turn acts on the C4. That is, it activates the C4, and it is broken down into C4A, C4A and C4B. So this C1 and C4B, it combines to form C14B, that in turn acts on C2, another complement protein, which is again broken down into C2A and C2B. This C2A is, it binds with this C41B to form the C14B2A, that is the C3 convertase that acts on the C3. It acts on the C3 and breaks down C3 into C3A and C3B. Now this C3B is again acted on by, it is this binds C3B binds with this C14A, this C3 convertase to form the C5 convertase. Here C1, 4B, 2A, 3B, it is the C5 convertase, which breaks down C5 into its component, that is C5A and C5B. Now this C5B combines with C5B combines with C7, C6, C7, C8 and C9 complement protein. Together they form the C5B6 7, 8 and 9. This is the membrane attacking complex that forms holes inside the plasma membrane and help in the lysis of the cell. So this is basically the classical pathway. Now I am drawing the lectin pathway in another color. Now lectins are actually the mannose binding lectins. They are present on the outer wall of the cell wall of the bacteria, and this membrane bounding lectins MBL, they are recognized by another protein at another enzyme MASP, that is the mannose binding lectin associated serine protease, and this membrane bounding this MASP and MBL, they together they form a complex and causes the breakdown of two things, two complement proteins, that is the C4 and the C2. They are broken down into their components, that is C2, C2A and C2B, C4A and C4B. So this MASP and MBL combination, this complex, they causes breakdown of C4 and C2, and then we see that the C4B, it combines with the C2A, that is the C4B and 2A. Now this is the C3 convertase of the lectin pathway. Now this C3 convertase of lectin pathway is bit different from the C3 convertase of the alternative pathway. In composition it is different, but otherwise it has the same function of breaking down this C3. And in course of time, ultimately there also we see this membrane attack complex type. Ultimately C3 is broken down, then C5 is broken down. Ultimately the membrane attack complex is formed. And in the alternative pathway also we see that alternative pathway is activated by the endotoxins that is present on the surface of bacterial wall, on the surface of the yeast wall or any other venom. They trigger the alternative pathway. And what these all these bacterial endotoxin, venom or other things, they convert the C3 into C3B, and this C3B is again, it acts on it combines with factor B, and it breaks down the factor B into BA and B. So this C3B is again, it binds with this factor BB to form the C3BBB. Now this is the C3 convertase of the alternative pathway. So we see this C3 convertase of the alternative pathway is also different from that of the lectin pathway and that of the alternative pathway. But nevertheless, now there are also effects of the complement fixation. We have seen that the C3A has been a part of the C5 convertase, but the C3B, it is also having some function. That is, it activates the neutrophil as well as antigen presenting cells to phagocytize the foreign microbes. So this process of targeting the foreign microbe by this C3b is called the opsonization, and also another product, that is the C5a, that also attracts the neutrophils and macrophages to the area where infection is. And this process of attracting the C5, attracting the neutrophil by this C5a to the site of infection is called the chemotaxis. And again, this membrane attack complex that we discussed in the last slide, the membrane attack complex, which is the last product of this complement fixation, they act on the bacterial wall and cause rupture of the bacterial wall. Thus, cell lysis of the invading pathogen is caused by this complement fixation. And also, as because the complement fixation, they activate these APCs, that is the macrophages, and also other APCs like mast cells and basophil cells. So activation of the APC by this complement, that is done by this complement, that is C3a, C5a, C4a and C5a. These three complements, they activate the antigen presenting cells, and thus the antigen presenting cells, they internalize the antigen, done the antigen processing, and then ultimately they showcase the antigen, and at the same time also release certain cytokines, and especially the serotonin and the histamine. Now serotonin has mainly inflammatory function, serotonin, and histamine, they have a vasodilatory function. That is, by vasodilation we mean that the vascular permeability of the blood vessel, it is increased, and more leukocytes can enter from the blood stream to the site of infection. Thus, it helps in reducing the amount of pathogen that is present in the site of entry. So we see these are the 5 effects of complement fixation products. Now about the answer solving, we know that earlier we have seen that in the B cell, they have this IgG, and this IgG region, this is the variable region of the IgG, and if this is the super antigen, so super antigen binds with the FAB portion of the IgG that is bound to the B cells. So the first option is correct. The second option, that is the super antigen, they activate the alternative pathway of complement system. Yes, the super antigen, it is activated, it activates super antigen like the endotoxins that is present, the lipopolysaccharides, the venom factor, they activate the alternative pathway of the complement system. So alternative pathway is the second last pathway that we discussed in the earlier slides. So it is the second option is also correct. Then we see that antigen with dominant epitope of amino acid repeat sequences. So we are talking about super antigen, not the antigen. So this antigen is different from the super antigen, because we know that antigen, they have a very specific sequence, specific activation, and the super antigen, they induces non-specific activation. So this second option does not have any connection with the super antigen. Antigen does not have any connection with the super antigen because mode of action is totally different. Now super antigen binds with the T cell receptors V beta and the MHC class molecule. Now in the earlier slides we have seen that if this is a macrophage or any other APCs, and this is the MHC molecule, I'm drawing it like this. This is the MHC molecule, MHC presenter molecule. Then if I am drawing the superantigen in yellow, so this is the superantigen that binds with the MHC molecule, and also at the same time the superantigen, it binds with another, that is the T cell receptor of a T cell. So this is the T cell, and this is the any other antigen presenting cell, APC, and this is the super antigen. So this is the super antigen. So super antigen binds with both the T cell receptor as well as the MHC class 2 of the. So with this, we come to the end of this question, that deals with both superantigen as well as the complement fixation. Hope you like this video. I will be making, as GSET is very close, that is, it will be in early November, Gujarat set. So I'll be now making more and more videos on this GSET, though I will be also making videos on net also. So hope you like this video, and if you like this video, please do share it with your friends so that it gets maximum views, and please do subscribe to my channel to get more access to such videos. And those who have already subscribed, thanks for subscription. And I do make videos on MSc and BSc syllabus. You can go to my channel and watch those videos on algae, fungi, lichens, bryophytes, pteridophytes, and cyanobacteria. Thanks for watching this video, and also please do comment on any new video on the topic you want me to make. Already those who have made comments on request on the videos, I am making them one by one. And thanks again for watching this video.